two springs have spring constants of 200 newtons per meter and 600 newtons per meter. The springs are joined in series end to end and stretched so that their combined extension is 0.8 meters. What is the total strain energy stored in the springs? So immediately we should think of either a half K1 x1 squared plus a half K2 x2 squared, or a half F x1 plus x2, which is a total extension. And so they both have the same force. So either way would be valid. So one of them we have K1 and K2, but in the other one we have x1, x2. So it's just a matter of finding the other. And I think it's personal preference as to which one is quicker, because one of these will involve finding the force, and then the other will involve finding the individual extensions. So let's go through the first method. So this would be through 1. So this would involve a half times K1, which is 200, times, what's the extension of the 200? Well, since they're in series, so they both feel the same force tugging at them. And so the extension will be inversely proportional to the spring constant. So if one of them has 3 times a bigger spring constant, it will have a third as big an extension. So 600 newtons per meter, that spring, that will have a third as big an extension. Which means in terms of the extension 0.8, that's split out into 4 parts, because one of them is 3 times bigger than the other. So if that makes sense, what I mean is that one of them will be a quarter and the other will be 3/4, because 3 add 1 makes 4. So one of them has 3 times as big an extension, and then the other has the extension for reference. So that's 3 plus 1 is 4. So 600 newtons per meter will have a quarter of the extension. So that will be 0.2. And then for 200, that will have 3/4 of it, which is 0.6. So we have a half times 200 times x1 squared. And then x1 squared here would be 0.6 squared. And then the other would be a half times 600 times 0.2 squared. Now, what we could do here is we could use knowledge from the second one, because we know the force term, or the K1 x1 and K2 x2, they both equal the same force. So whichever of these expressions is easier for me to work out, I'll just take out a common factor of a half, and then I'll do 200 times 0.6. So 0.6 times 10 is 6, times another 10 is 60, times 2 is 120. And then this will be times the 0.6 plus 0.2, which is the total extension, 0.8. So usually it's easier to divide, let's say 120 by 2, which is 60. So we've got 60 times 0.8, which is just going to be 48 joules. And the answer is A. So what did I use here? I used the fact that they're both going to have the same force, and that force will be K1x1 or K2x2. And what I mean is that x1 is F over K1 and x2 is F over K2. So we can use that to actually simplify this expression. Just to reiterate this, in case it wasn't clear, what I've done is I've taken out the half and then the force term, and then it's x1 plus x2. And the force term could either be calculated as 200 times 0.6 or 600 times 0.2. They should give you the same answer, and it's whichever is more comfortable for you to calculate. Hopefully that makes sense, but do let me know if there are any questions.